Okay, let's go ahead and start the video lesson here for section 3.1, which finally covers equations. So a lot of chapter 3 is going to cover, one-step, two-step, multi-step equations and inequalities as well. So a lot of the nuts and bolts stuff, definitely, the stuff that makes algebra what it is covered in chapter 3. The first part of your notes, we've got definition of a linear equation. What I did was I just wrote down a linear equation. That's an example of a linear equation. There's billions and different types of linear equations you can have. But I just want to show you what makes this a linear equation with one variable. Obviously, it has the one x in it. That's what it is. And it's an equation. It's an equation because it has an equal sign. That's what makes it an equation. And it equals something. In this case, it's x is going to have a viable solution that we can put. It might not be a whole number, might not be a perfect like integer, but it has a solution. We'll also talk about how sometimes they can have no solution or infinite solutions as well. But that's what makes this one solution. And also I want to make note, I want you guys to look that it's not really a huge issue for chapter 3 just as of yet, but this is something, again, looking forward that you will definitely encounter, which is, if you think about this, if you look at the power of the variable of the x term, I mean, it could be an n, it could be a letter, whatever letter it wants to be, it could be basically anything, but the variable has a power of 1. Okay, so it has a power of 1. If it has something else, let's say it has power of 2 or power of 3 or power, it's not one solution. The power, the exponent right there of the x term, or the variable term, is going to determine how many solutions there are, or possible solutions. So if it has a squared, it possibly could have 2 solutions. If it has a 3, it could have 3 solutions perhaps. But again, that's not something that really you have to worry about with this chapter. But what is important for you to know is that that number is 1. That's what makes it a linear equation. And if there's a 1 there, we don't necessarily have to show it, right? We don't need that 1 there. We can just leave that blank, and we know by inference that it's there. Okay. Now, the first property that is discussed in this chapter is the property of equality. And now this property is very, very important for pretty much everything algebra. But the property for this one is the same operation must be applied to both sides of the equation. You might have heard teachers in the past say, like, what you do to one side, you do to the other. It's kind of like the golden rule, right? What you do to one side of the equation, you do to the other. And that's really all there is to it. And the example that I like to kind of always talk about is like, let's take a really simple equation. Let's take a simple equation like 1 + 2, right? Not that you have any trouble answering that equation, but 1 + 2 = 3, okay? So that is a true equation because the left side of it equals the right side. 1 + 2 = 3, and of course the right side of it equals 3 as well. All right, so that's what makes it an equation. You can't just write down, like 1 + 2 = 5. All right, that is not true. So we've got to make 1 + 2 = 3. Now that's really not the point here that I'm trying to make, but just want to show you something about using that property of equality. Now, if you follow that property of equality, it basically states this: like, if you, let's say we added 5 to the left side, well, let's add 5 to the right side. Okay, so as long as you do the same operation and the same thing to both sides of the equation, you're still dealing with an equation. You still have an equation. So it doesn't any longer equal 3 on both sides. But the point of an equation is that one side equals the other. The left side equals the right side equals the left side. So in this case, now we have both sides equal to 8. So as long as we add or subtract or multiply the same thing to both sides, you're fine. You're fine. So let's say we want to multiply both sides by 2. So as long as you multiply both sides by 2, we're still dealing with an equation here. So now both sides equal, because both they did equal 8, and now we multiplied by 2, and now we got 16, right? And we can keep doing that. You know, let's say we divide this side by 4, we can divide this side by 4. You know, let's say we took the square root of the left side, and you can take the square root of the right side. So that's kind of a good thing to think about when you guys are solving algebra problems in general, which is just to follow that property of equality, meaning just as long as you do the same thing to both sides of the equation, you're probably safe. You're probably in a good spot. Sometimes people feel like, well, they didn't do the same thing to both sides, or they did the same thing to both sides of the equation, and like they feel like they're doing it wrong. And that might not always be the case. So sometimes you just fall back on that property of equality. As long as you're doing the same thing to both sides of an equation and you're doing it the right way, you're probably moving in the correct direction. Now, first type of equations we're dealing with in this chapter are one-step equations, meaning they only take one step to solve. For number 1, you have c minus 12 equals 7, and what you want to do is you want to focus in, laser focus in on the variable side, on the letter side, focus in on that. And that side, the variable side, is going to tell you what you basically have to do, because it's all about inverse operations, the opposite operation. So we see a minus 12 there, we see a negative 12 or minus 12, because you can think of it either way as minus 12 or negative 12. And we're going to do the opposite. So we're going to add 12 to both sides. So we're going to add 12 to both sides. Okay, so here we are using the property of equality. We're adding the same amount to both sides. Now, the purpose of right here is that these cancel. Those cancel. Now, what that is called additive inverse. And you want that to happen on these kind of problems. You want the additive inverse to happen because those cancel each other out. They make 0. So with addition and subtraction problems, you're going to be finding the additive inverse of the variable side. And now here's another thing. It's small, but it's also a big thing that you should do, which is rewriting the equation. Okay, you want to rewrite the equation every time you do a step in a problem. You want to rewrite it. So we're going to rewrite this one. That's really big. We're going to rewrite it. We got c equals, and then 7 plus 12 is 19. And that's it. All right. So that's the answer to that problem. It was 19 minus 12. If we check that out, 19 minus 12 does equal 7. All right. So these start off pretty easy. All right. Number 2, looking at that letter side. Looking at the variable side, we have plus 6 1/10, 6.1. So we're going to do the opposite of that, which is minus 6.1. And what we do to one side, we do to the other. All right? Those cancel each other off on the letter side. So all we're left with on that side is n. On the right side, it's a little bit tricky. All right? If we leave it in that order that it's in right now, the arithmetic's not going to work out. Now, one thing that you might want to kind of look at here is that these have different signs. We have positive 1.4 and we have negative 6.1. So really, when we do this, we really want to do the math. You know, if we're talking about paper pencil math, we really want to do 6.1 minus 1.4. We want to find the difference here. But if we're going to find the difference, we better put 6.1 on top and then 1.4 below it, because we're subtracting 1.4 from it. So that's what you're going to do. And so just borrow, do all that stuff. And so you get 4.7. Is that what that is? Yeah, 4.7. And then it's going to be negative 4 7/10. And the reason that it's negative is because the negative number, negative 6.1, had a higher absolute value. So if you think of it like a battle, think of it like a war, the negatives win. All right, number 3. All right, look at that variable side. We have plus 4, so we're going to subtract 4 from both sides. Subtract 4, subtract 4. These cancel out right there. And then you have -8 and -4, which makes -12. So we're going to write -12 equals z. And that's it. That's a one-step equation. That's why they're called one-step equations, because they really just take one step, obviously. All right, now the property of multiplication and division of, with the properties of equality with this is basically the same as above. Whatever you do to one side, you do the other. But, with addition and subtraction, a lot of times we're changing signs. With multiplication, you don't want to change the signs. So you want to remember, it's called inverse operations. Inverse operations means you want to do the opposite operation. So if it's showing multiplication, the opposite of multiplication is division, and the opposite of division is multiplication. For number 4, we've got 2v equals -8.6. What we're going to do is we're going to divide both sides by 2, because the opposite of multiplication is division. And what we do to one side, we do to the other. So we're dividing both sides by 2 right there. And just to kind of point out what happens here, on this side, those 2's cancel out, because that's what you want to happen. You want, on the variable side, you want the variable to be the only thing on the variable side. We want the, you've heard your math teacher say this, you want to get the variable, you want to get the x, in this case it's a v, but you want to get the variable by itself. So you got v equals, and then -8.6 divided by 2 is -4.3. Number 5, you have -t equals 4, and this one may appear to be like already solved, with one exception. We have the negative outside the parentheses, or not outside the parentheses, but outside the variable. And another way to think of that would be as if there's a -1 there. So -1. So that truly isn't by itself yet until it's just t and it's positive. So how we want to handle that is by dividing both sides by -1. All right, so those cancel off right there. And then you're left with t equals -4. T equals -4. All right, for number 6, this is our first example that has division in it. It has d over 4. D, a number divided by 4 equals -9. So when we have division, the inverse operation of division is, yes, of course, it's multiplication. So we're going to multiply both sides by 4. Okay, and the purpose of doing that is that on the variable side, again, we're always kind of focusing on that variable side. That's a very important side in an equation. And on that variable side, what happens is those 4's cross cancel. They turn into 1. They turn into 1, which is what you want. You want d, you want the letter, the variable in this case, you want d to have a coefficient of 1, or just d. You just want d. So you got d equals -36, because 9 times 4 is 36. So negative times a positive is negative. That's it. D equals -36. Now, number 7, I kind of have a system here that I like to always point out when, because number 7 is a problem where you have a fraction next to a variable. I always call a letter. So when you have a fraction next to a letter, you want to kind of know what to do, because I think sometimes people are confused by that. So when you have a fraction next to a letter, what you want to do is you want to flip the fraction. You want to flip it. Okay. So flip that fraction and then multiply it on both sides. Okay. So that is what we're going to do. So when we flip 6 11s, that becomes 11 6. So we're going to multiply the left side by 11 6, and we're going to multiply the right side by 11 6. See what's going on there? And again, let's focus in on that variable side and see what's going on over there. So the what's going on over there is a multiplicative inverse, not the additive inverse, but the multiplicative inverse. All those things turn into 1. Everything cross cancels. And that's what you want. You want everything to turn into a 1. And so x and 1x is exactly the same. And now it just becomes a matter of doing 12 times 11, 6. 12 times 11, 6. So let's think 12 is a fraction. And 12 and 6 can cross cancel. 12 and 6 can cross cancel, right? Just divide by 6. So that becomes a 2, and that cancels out, becomes a 1. So now it's just a matter of doing 2 times 11, which is 22. So you got x equals 22 right there. All right. Okay, number 8, and continuing on from number 8, those are examples of two-step equations. Those are examples of two-step. And now the rule is for two-step equations. Now these are very simplistic rules because there can be more to two-step equations. But in its simplest way of kind of explaining this, what you want to do is you want to deal with two-step equations by first undoing addition, subtraction, because algebra is all about the undoing of a problem. Because we're in a lot of times in an algebra problem, it's already solved. The answer, it already says it equals something, right? It says equals 5 or equals -10. So it already says it equals something. So when we solve a problem, we use order of operations. But when we're solving an algebra problem, we're doing inverse operations. We're doing everything backwards. Everything is backwards. So we're doing everything in reverse. And in order of operations gets turned around as well. So typically, order of operations, we don't do addition and subtraction first. We do a multiplication division first. But with inverse operations, it's all turned around, like I said. Addition and subtraction, you undo that first. And then second, you undo multiplication and division. That comes after, which goes against, I think, some of our best instincts, because that's what we kind of, it's been ingrained in our brains that we always do multiplication division first and multiplication or addition subtraction last. But if you just think of it like, think of it like putting on your shoes and your socks. Okay, so solving a problem is like putting on your shoes and your socks. When you put on your shoes and your socks, you have to do that in a certain order. You can't put on your socks after your shoes. You wouldn't do that. That would be weird. So you put on your shoes, or you put on your socks, and then after you put on your sock, you put on your shoe. Okay, and so taking off your shoes and your socks is like an algebra problem. It's like the algebra problem. So when you take off your shoes and your socks, you can't take them off in the same exact order you put them on. You've got to take off your shoes, then your socks, right? So your shoes are like the addition subtraction, all right? Your socks are like the multiplication division. So you have to do things in reverse. You can't necessarily take off your socks. And I've had students that have tried to tell me, well, I could take off my socks if I really try, and go ahead and try that. But that's really not the point. The point is that I'm trying to use this analogy to help you understand how inverse operations works, especially with multi-step equations. So for example 8 right here, for example 8, let's focus in on that letter side, focus in on that variable side. And right here, we have 6u, which is showing multiplication. That's multiplication. And then we have subtraction. We have -1. So you want to kind of focus in on that part and realize what you have to undo. And the part that we want to undo is we want to undo the -1. So we want to add 1 to both sides. So we're going to add 1 to the left side, and we're going to add 1 to the right side. Because what we do to one side, we do to the other. Now those cancel each other out. And since we just did a step, let's rewrite the problem. So now the problem is 6u equals 18. So there's the problem. So every time you do a step in an algebra problem, what's kind of important is that you rewrite the problem. It now becomes something different. So now 6u equals 18, and it's a one-step equation. So we're going to divide both sides by 6. The 6 cancel on the u side, and that becomes just u. On the 18 divided by 6 side, that becomes 3. 18 divided by 6 is 3. And there's what u is. U equals 3. Okay. All right. Number 9. Okay. We have negative 8/3 x plus 5. So let's undo the addition first. Undo addition because we're doing inverse operations. So we're going to subtract 5 from the left side and from the right side. Okay, and once you do that, you got to rewrite the problem. Rewrite the problem. So now you got negative 8/3 x equals, and then 41 minus 5. 41 minus 5 is 36. And at this point, it's a one-step equation. So we have, here's another example where we have a fraction next to a variable, fraction next to a letter. So when you have a fraction next to a letter, you flip that fraction and you multiply it on both sides. Okay, so we're going to flip it. You don't have to flip where the negative is, though, but also don't flip the sign. Don't make it positive. So we're going to do negative 3/8. We're going to multiply that on both sides. And all that cancels out on the x side. And all we're left with is x there. And then over here, we've got the math to solve there. So 36 doesn't divide by 8. If we think of cross-canceling, 36 doesn't divide by 8, but that's okay. 36 and 8 have a common factor, 4, which you can divide by. So you can divide both those numbers by 4, and then we can kind of simplify it a little bit. We're not going to simplify it all the way down to, to where there's a 1. But 36 divided by 4 is 9, and 8 divided by 4 is 2. So now we just can do 9 times negative 3, which is negative 27. And then 1 times 2, which is 2. So you got negative 27 halves right there. All right, number 10 has some decimals in it. So we're going to do, and I think maybe the only thing that's a little bit different on this problem is that it's kind of switched around, like but it don't get too hung up on the way it's written. We're still going to do inverse operations the way we normally do. So the first thing we're going to do is we're going to focus on the variable side, and we're going to add 9.27 to both sides. And then on the variable side, those are additive inverse. They cancel each other off. And let's do a rewrite. Okay, so 23.13 plus 9. So what is that? That's going to be 40. And that's going to be, what, 32? So 32.40 equals 4.5b. And now we're going to just do, we're going to divide both sides by 4.5. 4.5, and I think that's 7 something. I can't remember off the top of my head. Sorry. Okay. We're going to do 2.4 divided by 4.5. Yeah, 7. I was kind of right there. So it's 7.2. So B equals 7 2/10. Okay, now the next part is steps for solving a linear equation with variables on one side. And so a little piece of advice that I wrote down that you might want to copy down is that you always want to simplify each side. So always simplify each side of the equation. So when I say each side, I'm talking about on either side of the equal sign. So simplify the left side, simplify the right side by combining or collecting like terms as much as you can before using inverse operations. Okay, so we're going to simplify each side of the equation before we start doing the opposite operations, inverse operations. That's what we're going to do. All right, so for number 11, and by the way, make sure you just pause the video and make sure you have that written down. But for number 11, you're going to notice if you look at the left side in particular, that's got some like terms that can be put together. Let me fix that up a little bit. Right here, you got 9b, and right here we have negative 3b. Okay, now those are like terms, which make, when you simplify them, you have 9b and you have negative 3b. That makes 6b. So that makes 6b. And then you also have some constants here. You have negative 8 and you have 5, which add up to, well, actually, there's a difference there of negative 3. And then equals 21. We're just going to drop that down because nothing really happened to that. And from here on in, it's a two-step equation. 6b minus 3 equals 21. And we're going to solve this like we have been. So we're going to add 3 to both sides. So we're going to add 3 to both sides. And so now we got 6b equals 24. 6b equals 24. And now it's a one-step equation. So we're going to divide by 6. Divide by 6. Those cancel off. And so now we have b equals 4. And that's all you can do on that one. Now number 20, but number 12 has parentheses. Okay, and one thing with parentheses is that you want to clear them. That's the way you hear a lot of times in algebra, is that we want to clear the parentheses. Now we can clear the parentheses by distributing. So you don't want to put like terms together before you clear those parentheses. You want to take care of the parentheses first. You have to take care of the parentheses first, then put like terms together. So we're going to distribute, on this one, we're going to distribute 7. And right here, we're going to distribute negative 2. Let's do this for a second. And let's go ahead and do that. So 7 times 2 is 14. 7 times r is 7r. So minus 7r minus 6r minus 16 equals 24. And we're going to look for some like terms. So we got negative 6r right here, negative 7r and negative 6r, which makes negative 13r. So negative 13r. And then you also have some constants here that you can put together. We have 14 and we have negative 16, which makes negative 2. And then drop down the equals, drop down 24. And now you have a typical two-step equation at this point. So just add 2 to both sides and then divide. So add 2 to both sides. Rewrite it. So you got negative 13r equals 26. You'll notice, I do that every time. Every time you do a step, an operation in an algebra problem, especially when it comes to an equation, is that you want to rewrite the problem. It's always changing. That's how it's going. And everything's kind of always evolving and transforming into different numbers. So it's very important you write it down and you see it. All right, and now we're going to divide both sides by negative 13. Those cancel off, and now we have our answer. R equals negative 2. That's it for that one. All right, for number 13 now, I want to revisit that later, but I'm going to go ahead and stop the notes here, and I'll talk about number 13 when we get into section 3.2, because I think it's worth talking about because it has something to do with clearing fractions. So that's the end of lesson 3.1.